Hello and welcome back to this video series on static and dynamic data structures. In this video, we'll primarily focus on just looking at some different ways in which we can use arrays, so some array use cases. So we'll look at replacing nested decisions, searching for some type of item in an array, and then this idea of parallel arrays. And so let's look at first how would we actually replace our nested decision structures and use an array. All right, I'm going to skip ahead here. Let's see here. So on this slide here, we have a program that essentially just tallies up the number of dependents that an employee has. And so the end user can enter 0 dependents, 1 dependent, 2 dependents, 3 dependents, 4 dependents, or 5 dependents. And so you kind of envision a program where you have an HR representative and they're just asking their various employees in their company, how many dependents do you have? And then at the end of this program, it'll just give a tally of how many employees have a particular dependent account. So what I did here is I coded this program out and you can take a look at it. So this is the same program. So the flow chart here on the left, where my mouse is hovering, is what they've done here is modularize the program, and we'll get to modularization in some future videos. But what I've done here is did everything in the main method. And so let me just talk through this program and then I'll run it. So here we have we declare a single variable called DEP, short for dependents. And then we have an array. And then we initialize our array to the 5 different positions, or the 6 different positions. So 0, 1, 2, 3, 4, 5. And then we have our sentinel value that we're going to test against in our condition. And then we bring in a scanner object because we're going to ask the user for input. And then here, this is our primer. We're going to ask the end user to enter in the number of dependents. And then they'll continue to so the end user who is running this program, they can continually enter in dependents until they enter 999. Once they enter 999, it'll break the loop and go into the next statement on line 26. And then we have another looping structure that would output what was entered. And so essentially, if somebody enters and say, hey, I have 1 dependent, it'll increment this spot here in our counts array by 1. And so you'll see that we're using this DEP because whatever value they enter, either 0, 1, 2, 3, 4, or 5, it'll increment that particular position within the array. So if you run this program, it says enter dependents for employees or 999 to quit. So we'll say 2, I have 2 dependents. And this is, like I said, assuming that you're just going through, like I say, a file sheet and you're just entering dependents for each employee to get a tally of how many dependents that do your employees have. We'll say 0. This employee has 1. This employee has 1 dependent. This employee has 5. And then here, let's go and press 999. That should break us from our loop. And then here we have a tally. And so 1 employee has 0 dependents. 4 employees have 1 dependent, and so forth. So this may be like a helpful program in terms of figuring out which health insurance provider that we want to go with. So again, I think the big thing here with this particular problem is we can replace nested decision structures by initializing an array to 0. Because the other way of doing this, if we didn't do arrays, we had to have 5 different or 6 different variables, like counts 1, counts 0, counts 1, counts 2, counts 3, counts 4. But this here just allows us to use an array and increment the number of times that a user would declare how many employees dependents they have. So just one small example. The next example here is searching for an exact match within our array. Let's say that, and here I have an example of that. This is one example, but let's look at this example here on the right. Going back to the candy bars array. So we have string candy bars, and we know that this is an array because of the open and closing bracket. And in our array, we have Snickers, Twix, Almond Joy, and 100 grand. So in total, we have 4 items within our array. Snickers is at index 0, Twix is at index 1, Almond Joy index 2, and then 100 grand is at index 3. And so this is another name for this is linear search, where we're looking to find some item within our array. Let's say we want to find Almond Joy. What we can do is we can use a looping structure to process and go through our array, and then we can use a decision structure to determine if one of the items is within our array. So here what happened is that we'll just declare a variable int x equals 0, while 0 is less than candy bars dot length. So this may be new here, this dot length property. And what the dot length property does is it gets the total number of values within our array. So dot length gets the total number of values within our array. So here we'll go through our decision structure. We'll say if candy bars x, when it first starts off in this while loop, x would be equal to 0. And then we'll say candy bar 0, what is at position 0? Snickers. Is Snickers dot equal to Almond Joy? No. So it'll skip the block. And then it'll just increment x. And it'll continue to do that until it finds the value that it's looking for. Another thing that may be new here is this dot equals. Dot equals, whenever you're comparing 2 strings, you have to use these methods that belong to the string class. You can't just do something such as this. Right? And we'll get into more detail of why you can't do that. But for now, what you need to know is that you need to use dot equals. And there is another one called dot equals ignore case. I'll be this uppercase. And what that does here is it allows you to ignore the case, so the end user can put in lowercase al, and it will still actually find notify that that this Almond Joy is within our array. But let me go ahead and just do regular equals. And then if we were to run this, Almond Joy is within our list. And let me just do a clear here. And it's also outputting many different times here. So Almond Joy is not in our list. Almond Joy is not in our list. And then what it's showing is that it's comparing this one and saying, no, it's not in our list. This one is not in our list. But then when you get to the third one, it says it's in our list. Now, here's another item I want to talk about here. It's called a flag variable. And typically we use a Boolean. And so we'll say Boolean is found. And we'll flip it to equal to false. And then what I'm going to do here is that if this particular item is within our array, I'm going to flip the flag variable is found. It's going to be equal to true. And again, I'll just put a comment here that says this is a flag variable. And essentially what it's doing is it's raising its hand if it's going to be found within our as we're looping through the array. If it's in our array, we'll raise our hand to say that it's in our array. And then I would get rid of the else statement here. But then at the end of my looping structure, what I'm going to do is do another decision structure to see if the flag has been raised, or if the hand has been raised, or if the variable is found has been flipped. So I'll say if is found, if you just leave it like is found, this implies that it's true, or you could say if is found is equal to true. But both of these are the same thing. Is found equal true, or you could say is found. Then what we'll do is we'll just output all right. So so let's go ahead and run our code. And so here, and then we can also do an else branch to say that it's not an array. And this prevents us from having to have to output this item is not an array all the time, but essentially it'll only output, if it's found, it'll output that it'll flip the Boolean flag, and we could test to see if that particular Boolean flag variable has been flipped. So now if we run this, it'll still give us the same output. But if we were to change, let's say for instance, Almond Joy to 100 grand. Actually, let's not do 100 grand. Let's go ahead and do, let's say, payday. So here, if we say candy bars X, and so payday is not within our array, and we say candy bar X, so it'll cycle through each one. So through position 0, which is holding Snickers, through position 1, which is holding Twix, through position 2, which is holding Almond Joy, and then position 3, which is holding 100 grand. None of these equal payday. So then this Boolean flag it will never go into the block, and so it'll always remain as false when the program initially started. And so here we'll get to it'll skip the block and go down to this on line 26. If is found, then it will say, it will go into the block, but it's not found. So it will go to our else block and say item not in array. And I'm forgetting and here. So if we run this program, it should get us this output here. And again, this is an example of linear search. There is something called binary search, but binary search is a lot quicker because it basically slices the array, or goes to the middle, divides the array, but it has to be sorted first. But we won't get into binary array in this video, but I'm going to pause this one because it's getting a little too long. And then in the next video, we'll talk about parallel arrays and then multidimensional arrays. Stay tuned.